and I can just keep stepping through the code. Hi everyone, Greg here. So in the previous video I talked about how to start a program from within another program. So here's a quick recap. I talked about why you shouldn't be using system, and the proper way to do it is to use a fork and an exec. Basically the way this works is you have your original process, you do the fork, so now you have two processes, the parent one and the child one, and then within the child you perform an exec which will transform this process into the new program you want to run. So all of this should be very familiar, because what we're going to see next will be relying on this. So if it's not familiar, check out the previous video I've already made on the topic. Okay, so now what is a pipe? A pipe is when you use the output of one program to become the input of the next program. You're probably already familiar with pipes from the shell. So if we imagine a simple example, I want to do an ls of whatever is in the dev directory, and I get this very long list. Let's say that I didn't really want to know the full list. I just want to know how many devices are in the directory. I can do a pipe, this vertical line here. I can do a pipe, this vertical line, and the output of this program here, the ls, the output of that will become the input of this next command, which is word count. WC stands for word count, and the -l means only count the lines, not the actual words. And so when I run this, I see there are 222 devices at the moment in this directory. So this is the pipe. Now the question is, how do we do this programmatically? So we can have a quick look. We need the syscall pipe, okay, very shockingly. And if we look quickly at the description here, pipe creates a pipe, a unidirectional data channel that can be used for inter-process communication. So the output of one becomes the input of the next one. The array pipe fd is used to return two file descriptors. We're going to have two file descriptors referring to the ends of the pipe. So one of them refers to the read end of the pipe, and the other refers to the write end of the pipe. Data written to the write end of the pipe is buffered by the kernel until it is read from the read end of the pipe, right? So the pipe is this entity, you write to it at one end and you read from it at the other end. So if we have another look at our graphic here, in the original process we're going to make 3 pipes. Now the reason for 3 pipes is we want one for the standard input, one for the standard output, and one for standard error. We do the fork, so now each process will have a copy of those 3 pipes, and in the child process we're gonna tie the pipes to the standard input, standard output, and standard error. And so the new program then will just do whatever it's normally doing, reading from standard input, writing to standard output, and it's not going to realize that it's writing to a pipe and that it is data that the parent will be able to access directly. So this is the basic process. Now let's look at this in code. So now what I'm going to do is I'm going to go to this directory. I have a main here already prepared, and if we look at that code, here it is. And this is a very simple program. We're not using pipes yet here. What we do is we do the fork, and then within the child, when PID is 0, we are within the child. So there we do the exec, we do a simple ls, and then in the parent we simply do ending parent, and the exec will just as far as the child is concerned, once you do the exec, the rest of the program no longer exists, and so this printf will never be seen by the child. So that should already be familiar, and this is what we're gonna start with to create our program. So I'm just going to quickly compile this. What am I gonna call this pipe? Let's say main.c, and I run this, and then what you notice, we see the printf starting parent, the printf ending parent, and then the program ends and we get our prompt back before the child even had the time to turn into the ls and produce the output here, right? And this is exactly the same thing as if I had simply done ls. Okay, so now we're going to modify this code here, and we're going to introduce the idea of pipes. Okay, so what I need to do is before the fork, I will do pipe. What I give as an argument to pipe is simply the array within which we can have the file descriptor. So I need to declare this here, right? We have 2 because we have one for the read end and one for the write end. And for now, I'm going to do just a single pipe, which will be tied to std out. And I'm doing that for the sake of simplicity. And we're going to do a somewhat more serious application later where we're going to do all 3 pipes. So then here within the child now, I will have a copy of that pipe, and what I need to do is I need to tie the right end, let me see, yes, the writing end. What I need to do is I need to tie the writing end of that pipe to std out. So the reading end will be 0 and the writing end will be 1. std out. So another way of saying std out is simply 1, the file descriptor 1. So std in would be 0, std out is 1, and std error is 2. So now DUP stands for duplicate. So I've actually duplicated that writing end of the pipe, and since I've done that, I can now actually close both ends of the pipes because I don't need it anymore. Here in the parent, I can close the writing end of the pipe because I'm only going to read from the pipe. And so now what I'm doing is I'm doing a read from the reading end of the pipe and putting it into buffer. I make sure that my buffer is null terminated, and I will just print the output. Okay, so I'm going to save that, and now I'm going to make sure I compile. And if I run it, then what do we see? Starting parent, then that printf where it says output from pipe, and then this is the output from my ls, main.c and pipe, and then the end of the parent. Okay, so this is code where we did the essential here. We created the pipe and it's all working. But this code is, of course, very simplistic. It's very much bare bones, and it wouldn't do for any kind of serious application. Also, we have only 1 pipe, and I want to show you an example where we have all 3. So now I want to show you code that is more robust, and as a result, it's going to be much longer code, much more complicated code. But I'm going to walk you through it one step at a time. So basically, I have a personal library where I have written properly one of those a couple of functions that allow me to deal with this kind of code very quickly and very easily, and I'm going to show you this in a minute. Now my personal library, I called it technical, very original name. So in a minute you're going to see code and it will be prefixed TEC. So all of the functions you see prefixed in this way, they come from my personal library. Now we are, as programmers, all familiar with at least one application that actually does use pipes, and that is the IDE. Typically the IDE does not contain its own debugger. It is relying on another debugger like GDB, and the IDE is really just a GUI layer on top of that. So how does the IDE use GDB to allow you to step through the debugger, and how does it build that GUI layer on top of GDB? Well, we're going to explore this now in a minute. I'm going to show you a very, very simplistic IDE and demonstrate how this is done. Now, a couple of videos back, I talked about taking control of the terminal, and I created a mini library that allows you to do things like clearing the screen, using color within your IDE, moving the cursor around, And what I'm going to do in this video is I'm actually going to use this to create my simple IDE. So let's have a look at it now. Okay, so now we are in the directory where I've created my IDE, and I have another program in there, demo.c. So I'm going to show you this. So what demo is, it's a simple demonstration program, and I'm going to step through that program with GDB in the IDE that I'm going to create. And IDE is a big word here. It's a very simplistic one. You're going to see what I'm talking about. But I'm going to step through this code using the IDE that I'm going to create in a second. So this code just computes factorials. You might know what factorials are. If you don't worry about it. It's not important for the purpose of this video. The point is, here is some simple code, and we're going to step through that in a second. So I'm going to show you the actual code of the IDE now. Okay, so here now is the actual code of the IDE. So that's our main function. And what I'm doing is I'm just getting the contents of this file demo.c, so the one I've just showed you. We put this in a buffer. This is a function from this library, terminal control. We enter an alt screen. Then we display the contents of the buffer. So here, this is just showing the code from within demo.c. And then here we call GDB with this file demo. And of course, I've compiled demo with a -g flag so that it would actually contain the debugging information. And this function we're going to look at in a second in more detail. Here is how I pass input onto GDB. We're going to look at that in detail as well in a second. And then here I'm going to read from standard input. So these are basically the commands that I'm going to type into my IDE. As long as you don't type exit, we're going to pass on the whatever the user types in to GDB. And so the whatever goes into stdn in this program will pass it on to the stdn of GDB, and we just do this in a loop until the user types in exit. So you'll see in a second how that works. So launch process. Let's look at this function now. So here we are. That is the function. What we're doing is we create this struct that is just to keep everything organized within like a central struct. So here's where we actually create the pipes, just like we did earlier in the simple program pipe, but now we have 3 of them because we want one for standard input, standard output, and then the error. So now we do our fork. Then here in the parent, what we do is we close the pipes that we no longer need. So when it comes to the pipe that will be linked to stdn, we are only going to write to it, so we can close the reading part in the parent, and then similarly we can close the writing part for standard output and standard error of GDB, because we're only going to read from those. And then on the child side, what we do is we tie up with DUP duplicate file descriptor. What we do is we tie up those pipes with standard input, standard output, and standard error. So the GDB will be reading from this pipe, right? Because it's going to be the equivalent of its own standard input, and then it's going to write to the other 2. So now that we have duplicated those, we don't need them. We don't need the actual pipe anymore, so we can close them. And now we do the actual exec. All right, and then what are we passing on to exec? Well, basically, there was the command here, and then we process the command a little bit whether the split will split up there where there's a space because we have some arguments, and it is that split up array that we will pass on to exec, and this will actually launch GDB. So, and this then here is the end of what's on the child side of the of this fork. Right, so now that we've created the fork, what we need to do is we actually need to listen to the output that is being produced by GDB, and we do this in a separate thread. So we have two threads, one for the standard output and the other for standard error. So here are two different threads. And what I did here, when we go back to the function where I called it, so that's the command. And then here, this is the function where I want to process the output that GDB produces. And then this is the function where I pass on, where I want to process the errors that GDB might produce. So these are pointers to the function that I passed on. So if I go back up here, you see we have function here, function out, function error, and then I save them within this central struct that I've created here. So a function like this that is passed on, the pointer of which is passed on as an argument to a function, this is known as a callback, right? So you pass on a pointer to the function, and then later you expect this function to call back that function. So when I go back up here, this is my callback, and it is saved in here. So then this function is listening to the standard output of GDB, and once it has some output ready, I expect it to pass that on to my callback. So let's now actually see what it does. This is the function that is listening to the standard output of GDB. So this is where I stored my callback, and this is just some prep work to be ready to call it. And then I'm reading data from the read end of this pipe that's been tied to the standard output of GDB, and I am placing it in this buffer. This is, see the name here, buff stdout, whatever stdout does produce, I'm putting it in that buffer. And then as long as I'm reading any data, I am here, I just make sure the buffer is null terminated, and then here I'm actually calling the callback, and then I get ready to read some more, and I keep doing that until there's no more being read, right? And then for the function that's listening to standard error, it's basically the same thing. It's just writing it in a different buffer. It is reading from a different pipe, but it's basically the same thing. So it's calling that callback. What was the callback again? The callback was, let me see here, it's called IDE process GDB output. So IDE process GDB output. So now we have the function that does that. So there's this main struct again that deals with that, the launching of the process. So here is that main struct again that deals with everything that deals with the launching of the process, and managing the pipes is done through that main struct. So we're going to be reading from that buffer. So here I just have a pointer to that buffer. So now the kind of output that GDB will produce, sometimes it will begin with a number. And when it is a number, it is basically a line number, and it's telling us which line of the code it's running at that point in time. So what I'm doing is I'm just converting the string to an actual integer. I'm just going through that output, and then I am displaying the contents again, but I'm passing on that number. And in a minute, you're going to see, as I'm stepping through the code, that some of the lines are displayed in red, and it's basically that number that I'm passing on, and I'm saying that line number, because I'm passing through that now, I want that line number to be displayed in red, right? And then anything else that's not a line number, I want, well, or even those ones, the output that is produced by GDB, I want it to be displayed in yellow. And you're going to see that in a minute as I'm running it. And then here is where I process the errors. And this is much simpler because all I do is, if there is an error, I have it displayed in red. And that's basically all I do. Okay, so I realize this is a bit much. Hopefully you are able to follow through the logic. This code, you will be able to find it on the GitLab. There'll be links in the description. But now let's actually run it, right? So what do I have here? GCC-O. I'm going to call it IDE main.c. And then I did use pthreads, so I have to make sure to include that. And now is this, it does compile, we're lucky. So now if I run it, there we are. Okay, so what this is doing is this is displaying my the code inside demo.c. And did I show you that earlier? I'm not sure if I showed you, but the first bit of input that I passed on to GDB was put a breakpoint at line 26 and then start running the program. So this is passed on straight away. As soon as a process is being launched, that input is passed on to GDB. So you see that it has done that. It created the breakpoint, and now it has begun running the program at the very beginning. So that's line 26. And you see that this is indeed highlighted in red. So now I can choose step through the program. So I will press N and enter, and I'm just going through the next line in the program. So I keep going. And then if I want to step into, I just press S. This is exactly like using GDB. And then I press enter and I just step through it like that. And then if I want to know what's now actually the value of result, I can just do that. Now, yeah, this is not a good example here because actually result didn't, the code didn't even get to this point. It stopped here somewhere, I think. So that's why result has like this nonsense value here now. So let me continue to step through it. Now I can do pf, and f has value 1. And I can just keep stepping through the code. And if I look at pf now, then it has value 24. And if you know something about factorials, you know that that indeed does make sense. Oops. So next, I can step through it again. And this time it's actually going to go through that loop, right? And now if I do p result, I should get something more sensible, 120. So, and I can keep going this way. So it is very simple, but I think it still demonstrates the concept. This is how you use pipes. I basically have a separate program. It does input whatever I type here. It does, and in fact, if I pass this on to GDB, what it will do is it will say, well, undefined command. So this is from standard error, and you see how this is in red. I showed you earlier this function that was processing the standard error. It would display things in red. So that is what you see here. So we're just passing things on to GDB, and we just getting the standard output, and we're processing it a bit just to make it look a bit nicer and highlight our code. So again, very simplistic IDE, but it's just to demonstrate how pipes actually work. The last point I want to make is that what you just saw was a proof of concept. I didn't do the IDE properly, and in fact I did cut quite a few corners just for the sake of keeping the code very simple and getting this done very quickly. The way you would normally do this, if you want to run GDB properly in a way that is kind of tailored towards an IDE is that you would use this flag as you run it. And when you do this, then you see GDB producing output that looks very, very different. And it's output that is supposed to be parsed relatively easily by an IDE and get output that is much more appropriate to be processed and then displayed whichever way you want by means of a GUI. And I didn't do this here, again, for the sake of saving time and keeping the code simple and keeping it down to a minimum. So this is all I wanted to tell you. As always, I hope you learned something. I hope you enjoyed. And if you did, please give me a like, give me a subscribe. Thank you very much for watching, and I see you in the next one.